Hey everyone, welcome to Homework 2.9. So this one's pretty short. I'm going to go over it pretty quickly. The most important thing though that you do tonight is to make sure you do your review packet. Alright, so this is functions R and D. It gives the height of a rocket and a drone. And it is asking you to write each statement in function notation. So it says at 3 seconds, the toy rocket is higher than the drone. So to show this then, right, at 3 seconds here, the rocket is here, the drone is here. We're going to put R of 3 is greater than the drone at 3 seconds. Because remember, this whole function notation, R of t, gives us the y value. That's the answer. So R of 3, if we were to interpret that then, would be about here at around 36 feet, and then D of 3 would be here at approximately 20 feet. At the start, the toy rocket is 25 feet above the drone. So this would be R of 0 equals 25 feet. And it's saying above the drone. Well, the drone is at 0. So we could just leave it as this, or we could also say above D of 0, because D of 0 would be 0. So 0 plus 25 gives us 25. All right, number 2. A of t is the average high temperature in Aspen, Colorado, t months after the start of the year. M of t is the average high temperature in Minneapolis, So that red line is Minneapolis and the blue solid line is Colorado or Aspen. And temperature is measured in Fahrenheit. Okay, so which function had the higher average rate of change between beginning of January and middle of March? So let's first find that. So January is in the first month. This is the third month, March. Middle of March would be halfway through here, right? So that would be about here. And so we're looking at what is the change from there to here versus our red line from here to here. Okay, so, oops, excuse me. So here we can see that if we were to draw our line from here to here, and then draw our line from here to here for, oops, that's not quite accurate. Oopsie. There we go. For our slope, then this second line, right, our line for Minneapolis is steeper than our line for Aspen. So the function with the higher average rate of change would be Minneapolis. And it says, what does this mean about the temperature in the two cities? So this means in Minneapolis, the temp varies more from January to March, right? If we're looking at Aspen, it's, it does increase from January to March, but just not as steeply as Minneapolis. So Minneapolis gets colder, but it also reaches that warmer temperature as well. So that means that there's more variance or more changing in Minneapolis than in Aspen. All right, here are two graphs representing these functions. Functions f, which is this curved line here, and g, which is this line, frowny face looking line here. Select all statements that are true about the functions f of g. So this one is actually really important for your test tomorrow because you're going to see something similar. So f of 0 is greater than g of 0. So this is g of 0, this is f of 0. So that is not true because f of 0 is actually less than g of 0. There are two values of x where f of x equals g of x. So that is true. There is a value here and there is a value here where f of x and g of x are equal to each other. F of -1, so that's here, is less than g of -1. That is true. F of -3, which is down here, is greater than g of +4. So g +4 is here. Oh, whoops, actually, hold on, this one, that's incorrect. Let me erase that because that is, we're going to get f of -3, which would be here. So f of -3 is greater than g of 4. Looks like, yes, slightly, right? So you can see that this is slightly higher than that point right there. So on the quiz tomorrow, I don't know why this camera situation is the way that it is. I don't know if you can see me or not. Oh well. Anyway, so on your quiz tomorrow, you will see something similar to this where you need to decide which statements are true and which statements are false about a graph that is given. So just be prepared to be able to analyze that. Remember that the input is in the parentheses, and then this whole thing is the output, right? F of 0 in this case would be here, okay? G of 0 would be here, and it gives you then that y value, that output. All right, number 4, the 3 graphs represent the progress of 3 runners in a 400-meter race. The solid line is runner A. The dotted line represents runner B. And then the dashed line is C. Which runner ran at a constant rate throughout the race? So we can see that person A ran for a while, then they kind of seemingly stopped running, and then continued running again. Person B was running pretty much at a nice even pace, a constant rate, but then started to slow down, and person C is the only person who continued to run at a constant rate. A second runner stopped running for a while. Which one? During which interval of time did that happen? So that is person A, and that is from a little bit after 10 seconds, so about 15 seconds until probably about 45 seconds. So 15 to 45-ish seconds. Oh, I'm sorry. That is in the wrong place. So this should be here, 15 to 45 seconds. And then the third runner's race, so that's our dotted person here, person B, be as specific as possible. So as I said, B ran at a constant rate from 0 to looks like about started to taper off here. So 0 until about 20 to 27 seconds. Then slowed down. All right, D says, who won the race and how do you know? All right, so explain how you know. So they are doing a 400-meter race. So it's when they cross the 400 line, and that happened fastest for person C. All right, so you can see that person C here at a little bit before 40 seconds crossed the finish line. Person B crossed, they were just under, let me erase it so you can see a little bit better. They were just under the 400 mark until about 47 seconds or so, 48 seconds. And then person A started off really, really fast, then had to take a little break, stopped, and then they ended up crossing the finish line at around 53, 54 seconds, okay? So it's where we see them crossing this 400-meter line there. Function A gives us the area in square inches of a square, right? So area is side times side, or in this case of a square, since both sides are x, it's x squared. Complete the table. So 0, 1, 4, 9, 16, 25, 36. Represent function A using an equation. So A of x equals x squared. And then we're going to sketch the function of the graph. So 0, 0, 1, 1, 2, oops, I'm sorry, nope, this is not in ones, let me fix this. Okay, so 0, 0, 1, 1, so 1, 1, 2, 4, 3, 9, 4, 16, 5, 25, 6, 36, okay, 7 we could do is 49, right? So this is going to create a curved line. Function f is represented by f of x equals 5 times x plus 11 in parentheses. Find f of -2. So this gives me the x, or the input, so I'm going to replace x with -2 equals 5 times -2 plus 11. which is 5 times 9, which is 45. Find the value of x such that f of x equals 90 is true. So this is now I'm replacing f of x. So 90 equals 5 times x plus 11. And I could go ahead and distribute, or I can also just divide 90 divided by 5, since that's a nice, perfect, even division there. And so if I divide both sides by 5, I get 18 equals x plus 11. Subtract 11 from both sides, and we get x equals 7. We can check that out and make sure that works. 7 plus 11 equals 18 times 5 equals 90. So I know that that is true. So this is a reminder that if we have the input, you're substituting for x. If you have the output, you're substituting for y. All right, that is it for your homework. So it's super fast. Check out the other video of your review packet and make sure that you study for your quiz tomorrow. It's a short quiz, and we will go over any questions that you have before the quiz. You can feel free to message me as well if you have any questions. Your code word for today will be NASA, since we have all this talk of rockets. All right, happy homeworking and see you tomorrow.